Hi, I'm Rainer, and this week we're going to talk about how to find the speed of a block that's being pulled when there's friction on the ground. So in this problem, we've got this block right here being pulled upwards by this force F0 at this angle theta. And there's friction on the ground, and I'll say with the coefficient of kinetic friction, mu sub k. So what we have to do to find the speed is to realize that the speed is only going to be in the x direction because this block is not going to be pulled off the ground or into the ground. So in order to do that, we can say we can find an acceleration in the x direction based on these forces and then use what we know from the past to get a speed out of that. So if I sum my forces in the x, I'm going to look back at this free body diagram right here where I labeled my system as my block and set up these axes so that the right is the x and the upwards is y. So I've got these four forces acting on it, and I notice that the only two with x components are this F0 and this friction force, which is pointing in opposite the direction of slipping. So to the right, we've got the x component of F0. So F0, and in this case it's going to be times cosine of theta. I have a plus sign since it's pointing to the right. And then I have minus some kinetic friction force. And that equals the mass of the block times the acceleration in the x direction of the block. Now, unfortunately, I don't know that friction force, but I know that it equals mu times the normal force. But this one's going to be a little bit weird as far as normal force is concerned, so I better sum up my forces in the y direction just to be sure I know what's going on. So if I sum them up in the y direction, you can see from the picture that I'll have the normal force plus F0 sine theta, the y component of this applied force, minus the weight. So I'll say minus mg. And since it's not moving up and down in the y direction, I'll put that equals 0. So I get the normal force, in this case, actually turns out to be mg minus F0 sine theta. So now I can come back over here and say, plug that in here for mu times the normal force. I can say, let's go back to equation 1 and say F0 cosine theta minus mu k times mg minus F0 sine theta equals max. Now I can clearly just divide by mass over here and end up with an expression for the acceleration. Now if I want to find the velocity from this, I know I have to take an integral, and I know I have to put something in the form of v of t equals v0 plus integral from 0 to t of a of t dt. I know that velocity initial in this case is 0 since it starts from rest, so I'll get rid of that. And I know when I take this integral, I just have a giant constant, so I'm just going to multiply it by t. So I won't write that again, but it will just be this expression times t0 in this case. And that will be our answer.